guys, I'm Andy. I'm amazed. It's 12 months, almost to the day, since Paul gave me some tips at the very first meeting I came here. And I got a picture that actually worked. And I was going, oh my gosh. I've been battling for all these months, and finally I've got a result. And I kind of find it amazing that I'm standing here a year later, talking to you good people about something as technical as this. So bear with me if I stuff it up. And I'm sure some of the more clever people here will certainly correct me on various bits of this, but this is something I've tried, something that happened, and something that was interesting. Just a bit of a recap. Those of you who don't know, my SB camera, it's a one-shot camera, had a little circuit failure issue and decided it needed to go for a holiday to America to go back to the factory and visit its family.
Is that why they call it one shot?
Mm-hmm.
He's good, he's good. He's good.
Which left me cameraless, which was a very strange feeling, because as you know, when you get into this hobby, this bug, this drive, this desire, it sucks you in it. You just sort of think, oh, what will I do? So I put out a cry for help, and Phil Hart was kind enough to respond, and he lent me his modded, cooled DSLR. First time I've used one of those. And it enabled me to take some pictures. What I didn't realise was that camera came with a hydrogen alpha filter. And I thought, ooh, this is interesting. What can we do with this? So essentially, this is a little bit of what happened over the last month or so. Playing with this. So here we go. Now you know the background. Oh, the camera's for sale, by the way. I'm to mention that. About $800 if anyone wants a modded, cooled DSLR. Talk to Phil Hart. I do not get a commission. Right, that was the first picture I took using that, and it was just with a 85mm lens. Edit Carina, because I was just pointing at something bright that I knew was up there, and I was gobsmacked that there's so much more detail in HA than I'd ever seen on a RGB picture before. So I was kind of going, ooh, this is exciting. Wonder what I could do with this next. By the way, quick show of hands, does anyone have a HA filter here other than Nick? 1, 2, 3, 4, okay, cool. And does anyone have, what am I looking for here? Who shoots with a DSLR? Okay. Most of you guys, okay, cool, excellent. Who shoots with a one-shot camera? That's most of the room. And the mono people, the clever ones? There you go.
Oh, hardcore.
There you go. These are the gurus. Okay. What I'm hoping to present here is that you can actually do this with a DSLR. Alright, it'll extend the range of the photos that you take. So, the technical bit. What is HA? Hydrogen alpha. This is from Wikipedia. It's an emission of 656 nanometers, so if this is your piano keyboard, these are the bass notes, these are the treble end, somewhere in there. This is blue, this is red, ultraviolet down there, infrared up here, and this little baby here, 656 nanometers, very thin little wavelength of light. But it's important to astronomers because it's emitted by many emission nebulae, e.g. what Nick just showed you. Okay? And then you get pictures like Nick's.
Oh, well.
There you go. Because these hydrogen alpha filters increase the contrast that's out there. So you effectively see a lot more detail, a lot more stuff that you would normally see from an RGB image. This is an example of a 6 nanometer HA filter. See that? 653 to 659, that's what those numbers are. Just a little bit either side of that wavelength, okay? So we're talking about not very much light at all that we're seeing. But here's the cool bit. You can do it in full moon and in light polluted conditions.
But not with cloud.
Ah, it's good again, it's good. Or if it's set again.
3 from 3. So what I discovered was, this is really cool, because on those nights when the moon's rising or setting, come midnight, you're basically stuffed for taking pictures, you can keep taking pictures, or the other way around. So it extends the opportunities we have, because here in Melbourne, in winter...
You could use it whilst you're waiting for the moon to set as well.
Exactly. Yeah. Cool. So some of the filters that are available out there. These are some of the brands that you can get. Astronomic, I think, is short for astronomically expensive. Astrodon, Bardic, Scientific, and others. And you can see it's got this quite unique colouring to it. So there they are. And there's lots and lots of different sizes available out there. From what I could tell from my research, pricing seems to be not much under 150, 400 plus at the other end. Price seems to increase with size, as in 1.25 or 2 inch or whatever, and the narrower the bandwidth. So if you have a 3 nanometer one, it will be probably cost you enough to mortgage your house.
I think they're about $1,000.
There you go. And the 12 nanometer one is obviously a lot less expensive. But they're available for a whole bunch of different cameras. For the DSLR, there's what they call a clip-in type. Has anyone seen a clip-in filter?
Got one.
I've never seen one before.
Yeah, I've got a LP. I've got a light pollution one. It's great.
There you go.
Yeah.
So basically, you take the lens off, and there's the mirror in your camera, and this filter sits between the mirror and where the lens clips in. All right. So that's pretty easy.
So you need adapters for different cameras for them, do you?
The one Phil has is specifically for a Canon.
Right.
Yeah.
Do they make them for Nikon? They're on the same thing.
Is-
I think it's on the
I can only show what I tried.
And you have to use EF lenses.
I think that's correct.
Is Phil's one for sale? Can I?
Phil's is
Yeah,
for
just
sale.
said, yeah.
Yes.
The filter?
No,
No, the camera.
He's selling the camera,
Oh.
then talk to him about the filters.
Yeah.
About 800 for the camera, did I mention that? CCD, you can get a filter that's mounted, so you can screw it into the nose piece. And for your mono CCDs, obviously they're unmounted because they go in the filter wheels. And the people will tell you about that. So, what happens here? HA filters and DSLR or OSC, only 25% of the light is going to reach the sensor. That's not much, is it? That's because, basically, what comes through this thing called a Bayer matrix is your red, green, and blue light. But once we put this filter on, we're only getting light into the red pixels. So what's basically going to happen is, bear with me on this, we just lost 75% of our light. Okay? This isn't a problem for Nick, because Nick has a mono camera. He doesn't have that filter. But for the rest of us, not only are we losing the light, but those other pixels are still doing stuff. They're generating noise. That's not good. Noise is bad. So, what are we going to do about that? You with me? You okay? Ask questions if you want to. It's taken me weeks to understand all this. Okay. Possible solutions. Take longer exposures. Take more of them. Something called binning. Does anyone understand what binning is?
No, I don't. I want to know
Does
more.
anyone not understand what binning is? Please be honest. It's
I do,
easier
but
that way.
don't ask me to explain it.
Okay.
Okay.
In absolute basic layman's terms, we're talking about combining pixels. So, for example, a 2x2 binning would be combining the green and the blue one there, for example.
And the red.
Please, technical people, stop me if I got this wrong.
And the red.
Exactly.
So
So-
it'll create a square of 4.
There you go. In Nebulosity, which is a cool little program that I use for my astrophotography, it has a little function in there that enables you to reconstruct your image with low noise binning. All that means is instead of having most of that information here just generating noise, now we can cancel those pixels out altogether. Alright?
In an SLR? Or just in an SLR?
Using your Nebulosity.
Ooh.
Alright? That article, written by Craig Stark, is far more technical and is available on the web. And it'll give you heaps of information there that you can digest at your leisure. Alright? I'll even give you the link. But it's very useful because this is written for crazy people like me who want to do more with their one-shot camera or DSLR. We're heading into the territory that previously only the very clever people with mono cameras and who shoot narrowband can do. You're all very quiet.
That's all right.
So, take a picture. This is the first picture I kind of got serious about shooting with Phil's camera and the filter. And again, I chose a fairly well-known bright object to see what I would get. And I was pretty happy that suddenly I'm seeing the snake here in 6559. Sorry, this has dropped off the screen a bit. A lot more stuff here in the lagoon that I've never seen before. And if you kind of compare that with the straight RGB image, it's all gone. It's all gone away. So I'll do that again. That's what's up there.
It's amazing.
That's what the RGB typical modded DSLR can see. And that's I'd be happy with that a year ago. But I'm greedy now. You know, I want more.
So you took the second one using the technique that you followed in
Let's recap.
It's the same camera, wasn't it? With
Same
that-
camera.
same camera
With without the filter.
and then with the filter.
There you go.
Oh, that's amazing.
So once again, that's what's out there.
It's a good image.
Was that with binning or not binning or?
It's doing what he just said.
Correct.
Oh,
Don't get hung up on binning. Don't get hung up on binning. Binning is basically taking that much, the information that much further. Okay? But I would keep this a little bit simple at this point and then extend your technique and knowledge as you go along.
okay.
So what were the difference in the exposures between this one and the colour?
Okay, good question. Thank you for that.
600 hours. Yeah.
Segues nicely onto here, really. So this is our RGB stack, 36 5-minute shots, 1600 ISO with the Canon.
That's the film camera 40.
Yeah.
It's about 3 hours.
Yes.
It's just trying to see if I can get the edge of that, but I can't get the edge of that on the frame.
What's the A?
And if it wasn't the DA, it'd be even worse.
And if it wasn't the DAS,
Modified.
What's
says
the
you would lose all the
It means
green stuff.
it actually receives some of the hydrogen alpha. The normal infrared
Ah,
filter
I
is
see.
extended
So
to
it's a
include,
Yeah.
it's,
So everyone understand that?
okay, because your normal infrared filter in say the 40D will cut off 70% of the hydrogen alpha.
Yeah.
So they've put a different filter in that actually includes the hydrogen alpha.
There you go.
And the cut-off's a little bit beyond that. So with your normal 40D, you'll see half that red unless you start pushing it in Photoshop.
And obviously it looks better on the screen than it does on that screen.
Yeah.
Is that taken from your home?
Yes, this is all taken from my backyard. My backyard is 2 blocks away. Okay. This is about as good as I could make that picture that, without the filter, look, using Photoshop and its friends. And that's all my usual layer stuff that I learned here from Phil Hart in December's talk. So using your luminance, your curves, your levels, Silver FX Pro, colour, levels, curves, saturation, all that tricky stuff in Photoshop. You've all done that now?
Some of it.
Some of you have?
Did you take some darks and subtract them and use flats? Yeah,
No flats.
no flats, but
No
darks.
flats.
Yeah.
But some darks. Yeah. So are we still with me? Please put your hand up if you're not, because I've been dumbing this down as much as I can. It's taken me a year to learn it, so it's pretty dumb. Alright. This is cranking it with Nick filters now. So
Wow,
it's
that's
taking a nice picture and then obviously trying to make it pop even further, and just starting to get a little bit of the detail in here and a little bit of this here, but because we don't have the HA filter on there, all that information's, well, it's up there,
It's invisible, yeah.
but I can't see it. The camera can't
And
see
what
it.
there is of it will be very noisy.
Exactly. So,
And Nick filters?
Nick filters, download from Google. I think it's about $147 for the kit. I use it in my professional photography, but it's gobsmackingly easy to use, great filter pack. It's a plug-in for Photoshop. It's a really good investment. NIK filters. Alright. That's them there. NIK.
Can you swap back to the other one? Because that's quite a big. Yeah, look at that.
That's just using the filters.
Wow.
It's,
Oh no, more software.
if you looked at, just going back, if you looked at a single 5-minute frame or 35, what was it? They're 5 minutes. If you looked at a single 5-minute frame, amazing how little you can probably see on it.
True enough.
Yeah.
When you start, when you start with single 500 frames in these sorts of conditions, you don't see much.
Yes.
You have to sort of build up
Build up
the
the
image first of all by stacking it, and you have to remove as much of the noise as possible by dark subtraction and doing a whole lot of other stuff. So to get to that stage is quite impressive.
Yeah. So don't be disheartened if you out in the field you don't see much.
There's probably more in your data than you realise often.
1 year from last year, and I'm standing here doing this. Okay, so anyone can do this.
I hate you.
Andrew does have a background in photography.
Which helped.
Yeah, it helps.
But you can see what the Nick's doing just in there, just in like that area. You can see how it's picking up all the tonal contrast that's just hiding, if you like.
And it's doing it without increasing the noise substantially, which is quite impressive.
But it comes with a noise reduction pack in it as well.
Yeah, it also appears to be giving you a darker dark as well.
Look, there was always an argument about flipping blacks.
Yeah.
Now, in astrophotography, it's regarded as a no-no to flip your blacks. Okay, I'm a photographer. If I don't flip the blacks, the pictures look flat to me. So if I, remember I brought some award prints here a few weeks back. Blacks are clipped like crazy because they're being judged by photographers, not astrophotographers. So if they see a bunch of flat prints, they're going to go, oh jeez, you know.
You can clip them, but at the last stage, because if you clip them somewhere in between, then
Because you're going to lose
the loss.
information.
Yeah.
The idea is not to lose anything.
Yeah.
Yeah.
And
So
that's
right at the last step,
Yeah.
to make it look good. Yeah.
And
flip it.
obviously it's subjective, and as Bratislav says, you know, you've got control over this all the way to the end if you want to. Okay, let's get serious. Here's a stack of HA exposures now. This is 9 by 10 minutes. So that's 90 minutes. Yep. So 3 hours of RGB, 90 minutes of this. If I did this again, I'd probably do it the other way, because I reckon the HA data is actually more important.
Yeah, yeah.
Alright. But that's just my experience. But here we are. Also, I've run Nick through this to boost the contrast a little bit further and to really get this snake, I think it's called the snake, coming up here now. And it's starting to look, you know, pretty interesting. So now we need to put them together. Now, what classically happens, and that's your little layer pyramid, what classically happens here is you'll get a disgusting salmon pink colour. This is what we're here to try and avoid. Essentially, if you take a very bright red thing and you put a bright torch behind it, what colour is it going to be?
Less bright
There you go.
in terms of red.
There you go. But in addition to that, we've got another problem. Our stars. The star sizes. The star sizes in our RGB are bigger than the stars that we are seeing in our HA. If you just flick back, see those stars? They're teeny tiny little stars. I'm not talking about the ones from the projector.
Yeah, it's a bit hard to tell.
I'm talking about the ones.
They're well focused though.
Yeah. Well.
I'm talking about the ones in the HA. So, but now we're trying to mismatch tiny stars with fat stars, and that's always going to look weird because if we just do that as a layer of luminosity, it's going to look dodgy. You can see how it's going to have basically a halo around it.
Yep.
You see that? And that's pretty ugly.
Yeah, it's distracting, isn't it?
Yeah.
When you're looking at it.
Yeah.
The one on the extreme left is very blue, isn't it?
I should probably also point out that I think I overexposed the original RGB a bit because I'm not really familiar with the DSLR yet, so I think I kind of blew out the stars a bit to start with. But how are we going to get around this?
Give it to Phil.
Bear with me. We've got some Photoshop stuff to talk about for a
Give it to
second.
Phil.
Alright? Okay. Option 1. We could blur the colour layer. You know how we've got the luminance layer and we've got a colour layer, alright? You with me? The colour layer has got our RGB and the luminance layer has got our HA, and this is Photoshop, one sitting on top of the other. We're not that interested in the detail in the colour layer. We just said that. So what if we blur it? What if we just go Gaussian blur, blur? No stars.
Yeah.
We just got rid of all the RGB stars.
Except for the ones.
Except for these ones here. But our colours, we haven't done anything to fix the colours. And you might not like teeny tiny HA stars. You might think, you know what, I really don't want big blown out stars, but I don't want teeny tiny little ones either. So what do we do about that? Here we go. Put your Photoshop hat on for a second. And all of this is on the net and you can download this. You know how we have channels in Photoshop? You with me on this? Red, green, blue? Anyone not with me on that? I need you to get this bit. We're going to take the red channel from our RGB and we're going to copy it. And then we're going to drop it on top of our HA image. Everyone got that? We just took a little piece, our red channel, from our RGB and we put it on top here. And then we blended these two together, HA and the red, and now our stars are the right size. Okay? Anyone not got that? Because I'm happy to say it over and over again because it took me about 25 million times to get this.
So effectively, what you're doing is you're keeping the nebulosity of the H alpha, but you are disguising or hiding the stars by using the red channel stars.
There you go. In addition to that, we're also trying to keep a balance of aesthetics between what we want to see and what we can see with the two different mediums. All right.
You're sort of copying the bigger RGB stars into the
When you
luminosity.
do this in Photoshop, you can actually just change your opacity and you can see it changing in size quite easily. If anyone doesn't have Photoshop, I think you can do this in GIMP and probably in Photoshop Elements as well. It's not that hard, but the rewards, I think, are huge. So what have we got now? We've got a black and white picture with real stars in it. My slightly overblown stars from the first place. Okay. Here we go. Layer upon layer upon layer. It's like building a cake. So now we've got our new HA red image layered back on top. So remember that black and white picture we just had a second ago? Now we just put it back on top of the RGB, the original one. Remember that one? Blend mode luminosity, some tweaks, and bingo. We've now got a picture with the right size stars, and we've extended the dynamic range, and we've got all that wonderful stuff that we were looking at before, now in colour.
So you have the colour over top of the
There you go. So this is a lot of layers here. Okay. So here's our RGB. Remember our RGB one? That's the basic one that came out of the camera. There's the blurred one. I turned that off because we didn't want that one. There's the HA. We're not using that now. This is the HA and red. You got me on that?
Yeah.
So that's now sitting on top. And then we've tweaked it a bit with Nick at the end to try and get our colours looking more or less where we want them. And as you can see, it's rather pretty on that.
Oh, God, the connector's gone.
That's pretty on this monitor.
Yeah.
Yeah, that,
Doesn't look so hot up there, but you get the idea. So let's plug that back in and continue on. Just give that a second to find itself again. Give me the back. Okay. So, any questions to this point? Can you all rush out and buy hydrogen alpha filters now?
Still got the halos out a little bit,
Indeed.
Have you tried to just replace the red channel with the combination of the two? Because that's my favorite.
Okay. So Brightstar's going to share something here.
Yeah. So once you mix it to your liking, and you just replace the red channel, and suddenly all the nebula is actually red. So there's no summer because you need in the red channel only.
And the stars?
The stars you got from your red channel.
Yeah.
So they blend with the original stars in the right mix.
So there you go. So you could also, in theory, if I've got your suggestion correct there, you could take that red channel, put it back on top of this.
Well, not on top, but just replace the red channel because you got RGB,
Yep.
you got your three channel.
So there you
So
go.
don't mix this is in the luminosity. Just
Yep.
use it as a red channel. And you can actually mix them and change the opacity, and you can actually see how much your stars,
Yes.
because they will shift a little bit as you.
So, Brightstar's been doing this for years, and he's got some fair bit to share there.
The extra nebulosity bit appears sort of brown in this,
Yeah.
but if you do it your way, it comes out as red.
It could be a bit
Well,
of
it
a
should
monitor.
be. It is HO.
But
Like
it's not
the
really
monitor
red
issue.
in this image.
Come and
No,
have a
it's
look at
not,
it, Mark.
because it's still using as luminosity.
Yeah,
most of
but
it.
that's my
Yeah.
point. Sort of, yeah.
So let's just go through that again without the little titles. So here's our original file, stacked, Nick filtered, HA, bleh. Still bleh. Although kind of interesting if you just wanted to get nebulosity in a nebula without the stars distracting you. Kind of interesting. The tweaked version and the final composite. That's kind of cool, isn't it? Kind of cool.
Yeah, I think the reason it looks brown is because of the screen. The black is actually just showing you what's on the screen.
As I said, it looks pretty good in this monitor, so.
I need to look on that one.
So that was my experience with that one, and then I tried a couple more because I was keen, but then of course, ran into some dodgy weather. So here's a straight RGB of M16, which looks extremely average, particularly in line with what we've just seen from Nick. But, a year ago I would have been happy with that. There's some HA on the same object. Not hours and hours and hours worth, but, a bit. But you can start seeing, some more wispy nebulosity and stuff coming in there. And I think if you, like Nick, really extend your subs longer and take more of them, then obviously you'll get bucket loads more. There's some stunning pictures out there on net of this thing. And that's the bad marriage. And that's the better marriage. So it's not a great example, but I was having fun.
What that actually does show you, just before you disappear, is if you look at that, you can see how much red is actually around it.
Lots of heaps.
Yeah, but often you don't see that.
Every time I leave the red light on the dome, I see lots of red.
You won't see it, people have the idea that the Eagle Nebula is mainly around that central part, but
there's
just
heaps.
about everywhere around it is also got
Even on this monitor.
hydrogen. Yeah.
It's pretty good.
And it even shows up on there.
So that was my experience. Now another interesting thing happened. They say when you want to learn something, you should try and teach it. So I didn't know this very well. So when Nick said, "Hey, you want to share this?" It's like, yeah. But I was lucky. I'd been Facebook friends with a few astrophotographers, and anyone who's not on Facebook, I think you're missing out on one interesting resource, and that's the sharing of knowledge. I'm now Facebook friends with Robert Gendler. You're probably going to say, who's Robert Gendler?
Oh God. I know.
Anyone not know who he is? Okay, Robert Gendler is probably one of the top in the world.
God, yeah, it's
Astrophotographers.
God.
He gets access to Hubble data and all the amazing Subaru and all those telescopes. He's now my Facebook friend. He looked at my page. He liked my pictures.
You got a mic for him. That's what you
We're going to have to start issuing sick bags like that.
Anyway,
No, that'll only be when he sort of
I was
says,
slightly-
"Oh, this is the photo that Robert and I took."
I
Yeah.
was slightly starstruck.
Don't get too many selfies.
But I did trip across this chap in Perth, Paul Story, and he's much smarter than I am, and he uses a much bigger telescope. Profile of a Chilean poet's face called Gabriel Mistral. And this is the gem cluster. Okay. It's a good target. It's cool. I spent plenty of nights trying to shoot this thing. That's what it looks like in HA.
Wow. Oh, wow. Wow.
Alright. There you go, Nick. Next target, mate.
I think it could be well described that once you've seen it and you've taken a hydrogen alpha filter, you just can't go back.
You're not going back.
Just get one.
You're not just not going
It's
back.
just an amazing nebulosity there that you just don't see any other way.
How many days exposure is that? I mean, hours?
I didn't think about that. But look, you can do this tomorrow. You've got a DSLR. You can go and buy a filter.
Clouds, bloody clouds.
Get your credit cards out.
Can't do it tomorrow.
Isn't that amazing?
I just wish you could do it on the day as well.
You got it.
You've got to get rid of it.
That would help.
How cool is that? It's all up there.
That's
You just
Andrew.
can't see it.
Andrew Campbell.
Gabrielle Gatter.
Gabrielle. NGC 3324.
3324.
NGC 3324.
Put that in the 2-day
And
list.
it's in the edge of Korea.
Yeah.
It's a little on the edge of that arena. It's in the nebula itself.
3324. 3324, is that right?
3324. 3324. If I go back to that very
I'm guessing it's got quite a high magnification.
Yeah, I'm
on
guessing.
focal length.
Yeah, what is it, a 3 metre scope? Or,
Let me just help you here.
It's pretty wide.
yeah.
Just
Do you think so? Oh, okay.
Yeah, there it is.
Where's my way back?
224.
Yeah.
NGC 3324.
Oh, okay, it's that bit.
That bit.
And then just saying not
And that's that bit. See, that's what we're talking about here.
Jeez.
That little bit there.
Oh, it's still
It's pretty high.
That's
Yeah.
a lot of
a bit more magnification.
Yeah.
Yeah, but that's 85 mil.
Yeah.
Yeah.
It's not full frame yet. It's been cropped.
From memory, this guy is using a pretty serious
Parent size up 12
Newt.
minutes.
I'm guessing
It's
it's
a big light bucket he's got there.
that's probably about 2,000 mils or something.
Yeah,
But you don't think it's
All right.
Well,
I
carry
say it's
on.
clever.
Still depending on how big tube. But
So here's our not good marriage of HA and RGB. So what he's done here is he's brought in the HA data and he's put it under the RGB as luminance. And I should point out that he's shooting LRGB, he's shooting mono cameras here. So this is, you know, someone who knows what they're doing. It's better. But now it's starting to look holy. HA red, HA and RGB. Layer upon layer upon layer.
And that's the small version.
There you go. But check it out. Now we're getting somewhere. One more. With deconvoluted stars. This is
Yes.
something he does in a program called PixInsight.
Pixels, yeah. Okay.
And deconvoluting is what?
Making them smaller and sharper. You can also do this in nebulosity.
Bit of maxing as well.
You just have to be careful in nebulosity, in my experience, what I've tried. If you go too far, you get black circles around stars.
Yeah, ringing.
Sorry again.
You'll get that in PixInsight.
Right.
Yeah,
Maybe they do actually have they've cleared the stars have cleared away the nebulosity.
Maybe. But check that out. How good's that? There you go. That's someone who actually knows what they're doing with this technique. I was going, ooh, that's nice. Cool. And all of this because you just put up your hand and say, hey, how'd you like to, you know? I just love the sharing that's out there. It's just got some. There you go. There's the steps. Sorry, I just can't get the one on the end to come up onto this screen. My bad. That's much of it as possible. That's it. Yeah, smooth across. But you get the idea. There's your HA, there's your RGB, HA, RGB, HA, HA, RGB, and the final one.
So, Andy, can I just check? So, the HA, the final HA image, you're using it as a luminosity
Correct.
there. Whereas I know there's other techniques like in PixInsight where you can just swap it for the red or whatever channel.
you normally mix it, you can't just swap.
All of this is stuff that you need to play with yourself.
You could fiddle around yourself, yeah.
Season to taste,
Yeah.
etc. But needless to say, on this journey, as I said, there's lots of other people doing this. Some very clever people doing this, and some of them are been doing it for a lot longer than I have. Here's another one they shot. Does anyone recognise this little baby?
So the Swan.
Yeah, excellent.
M7.
Very good, M17. knocked off in 16. So that's your LRGB. There's your HA. A lot more stuff up there, isn't there? I've never ceased to be amazed how much stuff's up there. And that's what happens when you put it together.
Oh wow, yeah, that's good.
That's pretty, isn't it?
It's got fire.
Huh? Don't get there.
Looks like a what? A work.
Let's go back. So there's our LRGB and our HA and our merge of HA red with RGB. It's pretty, isn't it? But as I said, there are many clever people doing this. Some of them are in this room. These are from the ASV Yahoo group site, so with your permission, show this one. There you go.
Nice.
Author is in the room. There it is up there. But check that out. How much punch does that have? Remember that little bit that was over here before in the M8 shot I was showing you before? That's an absolutely stunning rendition of, I think it's 6559, if memory serves. How good's that?
Yeah, lovely.
You know?
Globules in
What are they? Star-forming regions or something?
Yeah.
Is that right? Globules. Anyone heard that term before? Has anyone not heard that term? We're talking about little black bits.
Yeah, dusty.
Globules.
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 Yeah.
There's a whole bunch of them in the running chicken nebula if you've ever tried photographing one.
Oh, okay.
No, you're allowed to use.
There's some files that he sent.
I'm allowed to use it.
Yeah. He's a user though.
Oh, user. Oh, God.
Speaking of the running chicken, this is the running chicken nebula, which is quite close to Carina. I think they're the block globules that we were talking about.
Now, how did he get that from the USA?
Yeah.
Probably remote, yeah. He's got users remotes, yeah.
A lot of the stuff that
Infrared remote.
And
he's
Hubble. And Hubble.
using is from the Hubble and from the Subaru and Spicer and all that stuff.
Probably
And
not
he's
that.
basically processing them, but some of it is his own as well. Yeah.
There is a remote telescope here in
There
Australia.
is. Siding Springs.
Sure, there's a few of them.
No, it's not the Siding Springs one.
Oh,
And some of his are taken with that, if I remember from his.
Okay.
He does actually mention some guy from Australia. I can't remember. I haven't looked at the site for a long time. But on his site, he mentions it.
He does work with Martin Pugh as well.
Oh, that could be who it is. Yeah.
Does a lot of conjunction work together.
And I think by this remote imaging. So.
Tell you that looks better on the screen than mine does.
Yeah.
But again, this is the composite. These are all composites using hydrogen alpha and LRGB in this case. It's amazing. You know, when you look at this on this screen, it's just.
What do we get on the screen here? We have to bring all these back.
That's the object Nick was showing us before, the cat's paw.
Got it.
Here it is. It's upside down because he's probably got it from the other hemisphere.
It's hanging.
But it's pretty gobsmacking, isn't it? Look at all the stuff that's up there. I think it just
it's
for me, that's the journey discovering all this. I think it's just amazing taking these pictures.
And that's just the stuff we can see with HA.
Yeah, not the other filters,
There's other stuff up there that,
Oh, yeah.
that you can't see with HA. Yeah.
Or dark matter.
This one's
You need a dark matter filter.
this one's often called the Lobster. It's actually quite close to the cat's paw in the sky.
lobster. I didn't know there was a lobster.
Yeah. That's got
Cats love lobster.
many names, but it's quite easy identified by these 4 stars in a row that
Yeah, that's good.
come in there. I've tried shooting that one. It's dim as all heck. So that would be lots of exposure. Lots and lots. So, most of what I've learned here is from this website, Starizona. If you Google Starizona HARGB, there is an excellent tutorial there. Alright, that you can read and digest at leisure. I don't expect you to understand all of this in half an hour. Took me considerably longer. But it's all there. Mr. Gendler himself, he has a page as well, and I'm allowed to quote it now. As well. And that one I was referring to earlier, which is from Stark Labs, from the guy who designed and created Nebulosity, is there as well.
And PhD guiding.
And PhD guiding and lots of other cool stuff. So, thanks, Connie.
Well, thank you very much.